We're going to look here at several examples of story problems, and we're going to first identify the model. And then once we identify the model, we will write the setup equation for that model for this problem. And then we're going to go through different visuals. So we'll do just a picture. We'll also show how to demonstrate the problem on a number line and then also with a strip diagram. So these are all visuals that could aid students with finding the answer. So when we identify the type or the model, that might be the same operation. So like, for example, if it's an add to problem, it might mean that you're adding, but remember that the type describes what's actually happening in the story, not the math that's happening, not what you need to do to solve the problem. And the same thing with your setup equation. So we might have an addition setup equation, but we might have to solve with subtraction, or vice versa. We might have a subtraction setup equation, but we might have to solve with addition. So we'll look at this first example. It says Kyle has 5 action figures. For his birthday, his mother gives him 6 action figures. How many action figures does Kyle have now? So if we look at what's happening in the story, before we even worry about finding an answer or writing an equation, Kyle had 5 action figures, so that's a starting value. And then for his birthday, his mother gives him 6 action figures. So we are changing the starting value that Kyle had. So that is an add to problem, right? We are adding to his starting value. So then if we want to write a setup equation for this, so if we look at our model sheet, we can see that for add to problems, the equation takes the form starting value plus the change equals the ending value. So in this particular problem, the starting value was what Kyle started with, which was 5 action figures. And then we would add to that the change, which was what his mother gave him, which was 6 more action figures. And then we're trying to find what does he have now, or what is that total? So that would be our equation for this one. All right, so then let's talk about how I could draw a picture for this. So we could draw action figures, and I'm gonna just do like maybe stick figures, but like it depends on how artistic you want to be. You don't want to take too much time. But the idea is let's just, demonstrate this. So if you're not super artistic, you could just use boxes and say that each box represents an action figure. So I'm gonna start by drawing the starting action figure. So this is what we're starting with. You had 5 action figures to start. And then how would I help a student through this or demonstrate this for a student? Well, the next thing I might do is I might just add on to that, right? So I would draw the change. So what did his mom give him? His mom gave him 6 action figures. So let me draw those. Six. So that is what his mom gave. And so then how could I find the total? Well, I could just go through and count, right? Or have a student go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we would get that, of course, by adding. So then what would the number line look like if we did this problem demonstrating it on a number line? So unless you have negatives in your problem, then I would just go ahead and put 0 kind of on the left end of our number line, but we would have arrows extending in both directions. As the student, if you're making a number line, you don't know how far out to go because we're using this number line to find the answer. We're pretending we don't already have the answer. So you don't know how far out you need to go if you're a student. Now, as the teacher, we know the answer is 11. So I know I need to go at least that far. So let me stick one more on there. So then what would I do? Well, I would pick a starting point. So it doesn't hurt to put labels on these. You don't have to, but I know we're starting with 5 action figures. So I could go ahead and pick that starting point at 5. And then we could do little hops, right? So then we're going to add to that what his mom gave him. So she gave 1, 2, 3, 4, 5, 6. So we're going to show that change in terms of what his mom gave him. His mom gave him 6. And so then how do you find the answer? You just see where did you end up, right? And again, if it helps, you can label all of these. Hurry up. And see that we end up at 11. So we know the answer is wherever we ended up, 11 action figures. And then last, let's do a strip diagram. So for this strip diagram, I would start with 5. So just draw a strip, however big you want, and label that as 5. And then what else do we know? Well, we know that his mom gave him more, and she gave 6 more. So when you draw that, you might make it look a little bit bigger than 5. And what we don't know is what that is now, right? So we don't know what that is, this new total. So that's what our strip diagram would look like. And so we can see, oh, 5 and 6 together make up the whole strip. So that's how we know to add 5 and 6. So let's look at the next one. So very similar. It says Kyle has some action figures for his birthday. His mother gave him 6 more action figures. Now Kyle has 11 action figures. How many action figures did Kyle have to start? So each time we do this, we're kind of pretending that we didn't do the last problem. And we're also kind of pretending that we haven't done the last thing. So like I would do with a student either a picture or a number line or a strip diagram. I probably wouldn't do more than one of those with a student unless they were struggling with one of them and I needed to try something else. So each time that we do this, we're kind of assuming we don't know the previous answer or haven't done the previous one. So in terms of what's happening here, so I think at first glance for a lot of students, they're going to see this and they're going to think, oh, this must be take from because I'm going to subtract. But remember, our model has to do with what's actually happening in the story, not how we're doing the math, right? So if we look at what's happening in the story, Kyle has some action figures. That's a starting value. I don't know the starting value, but that's a starting value. Then for his birthday, his mother gave him 6 more action figures. So we are adding to, right? We are changing that value by adding to it because it increases in size. And then we now have 11 action figures. So this is again an add to problem. So that equation still has the same form. It's still start value plus the change equals the end value. So for this particular problem, what's the starting value? That's what I don't know. So we use question marks for what we don't know. So question mark plus, do I know the change? Yes, I know that the change is what his mother gave. And then do I know the total? Well, I need to know at least 2 of these values if I'm going to solve it. And yes, we know that now he has an ending value of 11. So this would be our equation. And then we could go ahead and draw that. So drawing this one might be a little bit more difficult because it's a little tricky. Like, where do I start? If I don't know what the starting value is, then where do I start with drawing my picture? So I don't know what Kyle has to start with. But I do know the change and I know the ending value. So we could go ahead and we could draw that, right? So I could say, okay, well, I know his mom gave him 6, so let me go ahead and draw those. And you can use boxes or whatever you like. So this represents what his mom gave him. And then I don't know the starting value. I know what his mom gave, but then I also know the total, right? I know that the total or the ending value is supposed to be 11, right? So how would I find that, right? How would I figure out what that means in terms of what he had to begin with? Well, I would just count on to that, right? So I would go ahead and say, okay, I've got mom gave 6, right? I know I need to get to an ending value of 11. So let's just keep adding to that. So let's see, this is 7, 8, 9, 10, 11. And so now that I got to 11, how would I find my answer? I would just count those blue figures. So they might realize that you could just subtract. So you could, do it that way. Obviously, realize that, oh, if I end with 11 and mom gave 6, I would just subtract to see what that is. But if not, then you could actually use the picture to count those blue figures. All right, so then what about a number line? So the same thing, it's a little tricky here because you don't know where to start. So on this one though, we know that the ending value is going to be 11, so that means that your student should know that we need to go at least out to the number 11 when we put our tally marks, and it wouldn't hurt to go a little further than that either when we put our little tick marks there. Okay, so then I know how much we ended up with. I know how much the change was. I don't know the starting value. So in this one, what I would do is I would actually start with the ending value. So that's a little tricky, but that's the idea. Say, I know I'm going to end up with 11 action figures. Let's see if I go back, however many mom gave me, right? So mom gave me 6. So let's see. 1, 2, 3, 4, 5, 6, right? That's the ones that mom gave. And so then that means that since this was my ending value, then this must be my starting value. So you're kind of moving from the ending value to the starting value. And so we can say that the difference in this number line, notice the difference here. So like if we look at the one we did before, and it probably would have been good to label them there. So this one, this was our start and this was our end. And that is the same here, right? Start and end is the same. What's different is the direction we're going. So just note the difference in terms of that. That's really the only difference in the number line once it's done is that we started at the start and went to the end before. This time we started at the end and went to the start. All right, and then let's look at our strip diagram. So our strip diagram, we don't know the starting value, but we know that mom gave us 6 more. And we know that we end up with, when we put those together, we end up with 11. And so that would help us realize that, oh, since what we started with and 6 together make up the 11, we could just subtract 11 minus 6. So he had 5 action figures to start. Let's look at another one. Tanner had 8 Skittles. After his brother gave him more Skittles, Tanner had 14. How many Skittles did Tanner's brother give him? So if we look at what's happening in the problem, Tanner has a certain number of Skittles. We are changing that when his brother gives him some, right? So, and it says it gives him more, so we are increasing that. And then we have an ending value. So this is again an add to problem. So our add to equations look like this. In this case, I know the starting value is 8 Skittles. I don't know what his brother gave him, so that's my question mark. And I do know that we end up with 14 Skittles. So to draw a picture, let me just draw some Skittles. So I know the starting value. Let's go ahead and draw those Skittles. If you want to try and make them look like Skittles, you can. If you just want to do little circles, you can do that. So we start with 8. So that's our starting amount. And then we don't know what his brother gave him, but we know that we're going to have 14 total. So let's just keep adding Skittles until we get to 14. So right now we're at 8. So let's do 9, 10, 11, 12, 13, 14. And so that represents the ones that his brother gave. And so if we want to find what we're looking for, which is what did his brother give him, we would just count just those. Or we would realize that, oh, 14, and then if I take away these 8, then that would give me what's left, or what his brother gave. Which is 6. So then our number line, we know that he ends up with 14, so we need to go out at least that far. So on our add to problems, if we know the ending amount, then we know how far out to go. If we don't know the ending amount, that's when we don't know how far out to go. So we know the starting value, so we could go ahead and start there. So we started with 8 Skittles, and then we don't know how many hops we want to do, but we do know that we want to end up at 14. So we just count our hops. 1, 2, 3, 4, 5, 6. So there's not really an arrow on this one. There's not really a plotted point because the hops are really our answer on this one. So like we plotted points on the answer on the previous two. So like when we were looking for the ending value, that's where we plotted a point. When we were looking for the starting value, that's where we plotted the point. And we used the arrows to demonstrate which way we were going to find the answer. Here, we're not using arrows because the hops are our answer. And then for the strip diagram, we know our starting value. And I tend to put the starting value and the ending value, or the starting value on the bottom and then the ending value on the top, but you don't have to. You could technically put the starting value on the top and then the ending value on the bottom. It would make a difference. We don't know what his brother added to that, but we do know the ending value, that when we put the starting amount with what his brother gave him, we get 14. And so let's realize that we need to subtract. So I need 6.